Hi everyone, today we will learn the chapter 3 resources planning. And in this chapter, we'll go through four main parts. The first one is overview of planning, the second one is capacity planning, the next part is tactical planning, and the final part is short-term schedules. So let's take an overview of planning. So why do we have to make a plan? So let's say that you will have a midterm exam end of this month of three subjects, maybe marketing, logistics and supply chain management, and international trade. So you have exam for those three subjects, and you have to make a plan when you should finish studying the first subject, when you should study the second subject, right? To get the highest score for those three subjects. So for all activities have to be planned. It means that we need to design the timetables to show when they will be done so that we will finish all the activities in the best way. So how about delivery plans? For example, you have several orders and you have to deliver to you have to fulfill the orders end of this month. However, there are several orders you have to finish uh, in next month, for example. So you need to arrange when you should finish, when you should manufacture those orders, then deliver to the customers so that you can meet the customer requirement about time and also quality. So in delivery plan, you have to make the schedules for deliveries over the next month. If your organization does not plan for the future, it can only work from hour to hours without any continuity. And it's very dangerous if you meet some unexpected circumstance. For example, you don't make a plan for your delivery, so you need to deliver products to the customer end of this month. Then you just okay, uh, the day of end of this month I will just deliver to the customer. However, maybe the supplier didn't give you the products, the material on time, so that you don't have uh, scheduled time to meet your customer requirement. So that's why it's very important to make plan for everything, for all activities. And let's see how many type of plan we consider. So we have several several levels of planning, but what are mostly we will just consider the capacity plan, uh, aggregate plans, master schedule, and short-term schedules. So what are they? Capacity plans is the plans we are make to make sure there is enough capacity to meet the long-term demand. So the capacity plan is to fulfill the long-term demand. And the aggregate plans is the plans to fulfill the monthly demand. And the master schedules show the detailed timetable for all activities, typically by weekly demand. Okay, and short-term schedule is very detailed timetables for jobs and resources, typically by daily. So remember, for me, the capacity plans is for long-term plan. Aggregate plans is for monthly plan. Master schedule is for weekly. And three, this one we call it the tactical decision for logistics. And short-term schedules is for daily demand, for daily activities. And this one is the operational decision for logistics. Okay, so let's see what is the capacity planning. What is capacity? Capacity of a supply chain set the maximum amount of a product that can be delivered to final customer in a given time. So for example, I say the capacity of my factory is 10,000 products. So it means I only have enough space to produce 10,000 products in a given time. So capacity, here you also can understand like it's a limitation. The desired capacity is the maximum possible throughput in an ideal conditions. So we just assume an ideal conditions, and design capacity is the maximum amount that we can have their products. However, in the real life, there is no ideal conditions happen. So we have effective capacity is the maximum realistic throughput in a normal conditions, not in ideal conditions anymore. However, the actual throughput is normally lower than the effective capacity. So for some other constraint, other unexpected things, the actual output throughput is normally lower than the effective capacity. Okay, and not all parts of our supply chain have the same capacity. They have different capacity. So look at this flow of materials, this supply chain. We can easily see that the bottleneck is here. So, or here is also another bottleneck. So the bottleneck is what? Bottleneck is a supply chain, is the place that limits the overall capacity of the supply chain. So for example, the capacity of our here is 10,000, but then here is only 8,000, then here 9,000, then here 8,000, here maybe 5,000, then 7,000. So the smallest capacity, this area will limit the overall capacity of this whole supply chain to only 5 millions. And after we already solve this one, we need to find the bottlenecks to see where is the problem, where is the root of the problem. So after we find the bottleneck here, we try to solve the problem here. And after we solve this problem already, the next area we will look at is this area. This is the second bottleneck. So a supply chain will be managed effectively after we solve all the bottlenecks in the supply chain. Okay, let me give you an example so that you will understand more about bottleneck. We have the J&R soft drink company. And the main bottling plant has the capacity of 80,000 liters a day and works 7 days per week. And it fills standard bottles in 750 milliliters. And after finished bottling, they will pass those bottles to the packing area. And in packing area, they can form up to 20,000 cases a day with 12 bottles each case. And the packing area will work 5 days per week. And then those cases are taken to the warehouse by a transport company. And the transport company have 8 lorries, and one lorry can carry 300 cases, and they make up to 4 trips per day and 7 days per week. For the warehouse, they have 2 main warehouses, and each of warehouse can handle 30,000 cases per week. Okay, then local deliveries are made from the warehouse by a fleet of small vans that can handle everything passed to them by the warehouse. So we want to determine what is the capacity of this distribution system, and how can J&R company can increase the capacity. So here we have four main area here. First one is the bottling plant. The second one is packing area. Third one is the transport company, and the fourth one is the warehouse. Then after warehouse, that is the local deliveries. Okay, so let's see in we just solve one place by one place first. First one is the bottling plant. Then we see what is the capacity of the bottling plant. They have the capacity of 80,000 liters per day, and one bottle is 750 milliliters. Then we have here is how many bottles we can bottling. That is 80,000 liter divided by one bottle is 0.75 liter, right? So this is the total of bottle we can make in the bottling plant per day, and we have 7 days per week. So this will be the total of the bottle they can make in a week, and it's equal to around 746.66 something. That is for the bottle plant. We move to the next area, that is a packing area. So in packing area, they can form of 20,000 cases. So I have 20,000. 20,000 cases, and one case is 12 bottle, right? So multiply by 12. And they work 5 days per week, so multiply by 5. I will have the total of bottle the packing area can handle. So this is for the bottling plant, and this is for packing area. Next, we will consider the transport company. So the transport company have 8 lorries, and one lorry can carry 300 cases. 300 cases, and one case is 12 bottle, right? and they go 4 trips per day. So multiply by 4, and they work 7 days per week. So multiply by 7. Then we will have the total bottle that the transport company can handle per week. That is 8 times 300 times 12 times 4 and times 7. Next, we will move to the warehouse. So how many warehouse they have? They have 2 warehouse, and one warehouse can handle 30,000 cases. 30,000, and one case can handle 12 bottle, right? So multiply by 12. So we have the total bottle the warehouse can handle is this one. Okay, so here I have the number for you guys here: bottling plant, packing area, the transport, and the warehouse. And here we know that the local delivery can handle everything passed to them by the warehouse. So we know that the capacity of the delivery vans, the local delivery is greater than the capacity of the warehouse. Okay, so we have this system. The bottle plant can handle 746 something uh, bottles per week. The packing area can handle 1,200,000 uh, bottles per week. Transport company can handle uh, 806,000 plus bottle per week. Warehouse we can handle 720,000 bottles per week, and the delivery vans is the capacity of the delivery vans is smaller, is greater than the warehouse, so it's greater than 720,000 bottles. So here, when we look at here, we can see the bottleneck is here. The problem is the warehouse. So since the warehouse has the smallest capacity, so it limits the overall capacity of this supply chain, of this distribution system, and the overall capacity of this distribution system is 720,000 bottles per week. So we have to solve this problem. How can we increase the overall capacity of J&R company? We have to increase the capacity of warehouse. And after we solve the problem of warehouse already, the next problem we should look at is the bottling plant. So after increase the capacity of warehouse, if we still want to improve this system, we have to increase the capacity of bottling plant as well. Okay. And because determining the capacity is very important for a system or for the whole supply chain. So how can you determine the capacity of this system? For example, after you improve the warehouse already, you consider should you still look at the bottling plant, then how can you determine that? So our purpose is we try to match the capacity and the demand. The aim of the capacity planning is to match the available capacity of the facility to the demands put on them. Uh, so why we have to match the capacity and the demand? If the capacity is much greater than the demand, we have to pay higher cost for the extra capacity or the higher cost for inventory. However, if the capacity is smaller than the demand, we cannot fulfill all the demand. So we will lower our customer service level. So it's not good if the customer leave us. That's why it's important to match the capacity and demand so that we can balance. We can have the we can minimize the total cost, but also can satisfy the customer demand. So here is the main steps when you make the capacity planning. First, you have to forecast the demand and translate it into the capacity needed. So with those demand, how much capacity we need. Then the second step is we find the capacity available in present facilities. Here, the first step is we try to calculate what we need, and the second step is what we have. Then the third step, we identify the gaps between the capacity needed and the available capacity. And then we suggest the alternative plans for overcoming the gaps between them. Then we compare these plans and find the best plan. And after finding the best plan, we implement the best plan and monitor the performance. And this one is the standard approach to all kinds of planning. We can call it the resource requirement planning. Let's look at this example. Uh, the Amni Chankin company has a contract to deliver 100 computer systems a week to the school in South Wales. And it takes 1 hour to test the computer before delivery. The testing is done by the trained staff who achieve an average efficiency of 70%. They work 8 hours shift 5 days per week. It means they work 8 hours per day and 5 days per week. And they also can move to double shifts or have overtime at weekends. Then how many testers should any employ? So the first step that we need to determine how much capacity we need based on the forecast demand. So the demand is 1 hour computer system per week, and it takes 1 hour to test one computer. So it means they need 100 hours, right, to fulfill this demand. And the next step is we determine how much capacity we have now. So we have our one worker work 8 hours per day and 5 days per week. So 1 week they work 40 hours. And this one is in an ideal condition. So this is the desired capacity. But the actual capacity is they only can achieve the efficiency of 75%. So we have 40 multiplied by 45%, and it's equal to 30 hours. So what we need is 100 hours, and what we have is only 30 hours. So how many testers we need to employ? So it will be equal to the what we need, that 100 hours divided by 30. So it's equal to 3.33 tester. So we just here we just round it up to 4 because human, we cannot just 3.33 people, right? So we need to hire uh, 4 full-time tester. But if we only the actual one, we only need 3.33 tester, but if we employ 4 tester, we will have extra, right? So the utilization is only 3.33 divided by 4, so it's only around 83% if we are hire 4 tester. How about we the next option is we employ 3 tester full-time and 1 part-time, and that 1 part-time for 3 tester full-time, we can fulfill 90 hours, and we lack up 10 hours. So this the part-time tester will work 10 hours, so work 1/3 time. And with this way we can meet all the capacity with 100% of utilization. And we also can use the third option, that we hire 3 full-time tester and who are willing to do overtime over the weekends. So they work 90 hours for full-time, then they are do another 10 hour overtime at the weekends. And because the efficiency is 70%, so the extra time they have to work overtime is 30.3 hours here. So we have these 3 options, and we compare which one is the best one. So the first one is not good because it's only achieved 33% of utilization. However, the second one are and the second option and the third option, we can maximum their utilization. So based on uh, the strategy of different company, they will choose either the option 2 or option 3, or that they will employ 3 full-time tester. And if the work is so hard, so difficult, and if they care about their employer, they will not ask them to work overtime, they will hire one more part-time. So it depends on situation, they will choose either the option 2 or option 3. Okay. There are several practical problems with our capacity planning. We can see that the demand comes in a small quantities, but and the demand can take any value, but the capacity come in a large discrete amounts, so that we have to adjust the capacity. So we have 3 basic way to adjust the capacity. The first one, we are more than less match the capacity to the demand, so that sometimes the capacity will excess the demand, and sometimes there is a shortage. You can see here in the figure. So in this point that we have shortage, and in this point we have excess product. Also here is the shortage, then here is excess. So we can see the fluctuation in the capacity compared to the demand. The second way is we can make the capacity at least equal to the demand by early expansion. It means that the capacity is always exceeds the demand, and in this case we will need more investment in facilities, and we need to pay higher costs for the extension of the capacity, and this one gives lower utilization. And the third one, we only add the capacity when the additional facility would be fully used. This means that the demand always exceeds the capacity. They only open the new facility when the new facility can uh, be fully used. And if we use this way, we will have lower investment and higher utilization, but we have restricts the throughput. The throughput is limited. And each of these strategies will be the best in different circumstances. For example, uh, if the cost of shortage is high, or the demand is highly variable, and the spare capacity is low, the cost for the spare capacity is low, they will prefer using uh, this strategy, that they will make the capacity uh, at least equal to the demand by early expansion. However, if in the case that the cost of shortage is not much, and but their capacity is high cost, they will prefer using this strategy. And also we can consider changing their capacity concerns to the size of any changes. So we have the large changes and small change. So we can see here, for example, we need to hire for a staff, then we either uh, recruit for staff at the same time, or just separate the time of recruiting them. Maybe this month you recruit one person, then next month you recruit another person, for example. And it might be better to have a few large increase rather than the small one, because if you use few the few but large increase, uh, you can reduce the risk of not meeting unexpected demand, and also we can take advantage of the economies of scale. However, it also have a disadvantage that the gap between the capacity and the demand is larger, and the capital costs are higher, also lower utilization. So depends on strategy of each company and different situation. In the reality, we will choose which strategy is better to for your company. And we have two ways to adjust their capacity planning. First one is we adjust the capacity to match with the demand. We call it capacity management. The second one is the demand management, that we adjust the demand to match with the available capacity. So what is capacity management? What we do to manage the capacity, to adjust the capacity to match the demand. So for example, we lack of staff to serve the customer in the peak time. So we can employ part-time staff to cover the peak demand, for example. So we try to increase the capacity to match with the peak demand, right? Or we can use outside contractor. It means we hire the third party to help us produce more products to fulfill the customer orders. Or we also can rent or lease the extra facility. When we want to increase our facility, increase our capacity, we rent. And if we have extra facility, we can lease it to other company. Also, we can adjust the speed of working. If there are more customers, the speed of working should be higher to fulfill the customer requirement. Or also some supermarket let the customer to pack their own bag, like in Carrefour. So in the peak hour, they can make the customer to do some work, so they can reduce the work for the staff. That is several ways to adjust the capacity to match with the demand. How about adjusting the demand to match with the available capacity? We can vary the price. For example, if we have a lot of products, however, the number of customer order is a few, so maybe we can reduce the price so that we can attract more customer. Or also, we can use some sale or promotion to attract customer in not peak time. For example, if you usually see sale off for karaoke in working time, like from 8 a.m. to 4 p.m. from Monday to Friday, because during this time, just a few people will go to sing karaoke. That's why they reduce the price so that they can attract more customer to come to sing at this time, so that they can balance uh, the customer during peak time and during the working time. Or when you have high demand, you can use a reservation or appointment system to reduce and to make sure that you can fulfill all the customer requirement. For example, if you open a clinic and a lot of patients come to your clinic to have check up or something, then you can ask them to make a reservation or an appointment first, so that you can reduce the waiting time of the customers and also can improve your customer service. And in practice, that the effective capacity of a supply chain can change quite markedly. So basically, the complexity will change over time. An example for this one is the learning curve. So the more often you repeat something, the easier it becomes and the faster you can do it. So here you can see the learning curve. So the more you repeat it, the time you need for that task will decrease. For example, the cashier in the supermarket, maybe in the in the first few weeks, it takes them like 5 minutes to serve one customer. But if they work there for a month, maybe it's only takes them 3 minutes to serve a customer. And if they work there for 1 year, maybe it just takes them 1 or 2 minutes to serve a customer, for example. So the longer time, or the more often you do the job, the faster you can do, and more fluent you can finish that job. And also they related to the maintenance. So if you are the time between the maintenance period increase, then the maintenance cost will decrease. However, the cost of breakdowns will decrease. Therefore, we have the curve for the total cost is like this. So we can find here is the point that make the cost, the overcost is smallest, and we can find the optimal time when we should do the maintenance. Okay, that is about the capacity planning. And now we will uh, move to the tactical planning. So tactical plans will show us how the capacity will be used and developed in the medium term timetables for activity. The capacity planning is for the longer term, and for a long-term demand, but for the tactical planning is help us develop the medium-term timetable for activities. And here we also have several names to call this level planning, but most common aggregate plans and master schedules. So do you still remember aggregate plans? It used to satisfy the long-term, monthly, weekly, or daily demand. Okay, so aggregate plans is for monthly activities, and the master schedule is for weekly. Okay, weekly. Please remember that for me. So aggregate planning makes the tactical decisions. That is the medium activities, the medium time that translates the forecast demand and available capacity into the schedules for activities. So when we make the aggregate plans, we try to answer the questions that should we keep the throughput at a constant level, or should we change it to meet the varying demand, how we can control our stock level to meet the changing demand, how much should we keep for our safety stock so that we can satisfy the demand, or should we just vary the size of the workforce with the demand. For example, if the demand is low, we fire someone. If the demand is high, we hire someone. Should we do that? Or should we extend our capacity, like we use the subcontractor, or we use outside organization to cover the peak demands, or should we ask our full-time staff to do overtime? And also, should we all allow the shortage, perhaps with late delivery, or can what we can do to smooth the demand? So those are the basic questions we try to answer when we make the aggregate plan. So we have overall approach of making a tactical planning. So it's basically similar to the capacity planning. However, the difference is in the first step, we translate the forecast, demand, and other information into a demand for the resource. It's not in the capacity planning, we translate the forecasted demand uh, into the capacity needed. But here we translate it into a demand for resources. And in the step 2, we will try to find the resources currently available. So the first step, we determine the resource needed, the resource needed, the demand for resource based on the forecast. And the second step, we find the available resource. Then we identify the mismatch or the gaps between the resource needed and the available resource. And then we will suggest the alternative plans for overcoming the gaps or the mismatch. And then we compare this plan and find the best. And then we implement the best plan and monitor the performance. And basically, these 6 steps is quite similar to the capacity planning. Okay. Let's look at this example. A and B coaches of Blackpool plan their capacity in terms of coach days. So the forecast show the expected annual demands for the next 2 years to average is 400,000 full day passengers and 750,000 half day passengers. So there is what are there here is their forecasted demand. And what they have is they have 61 coaches with an effective capacity of 40 passengers a day, and they work to what 300 days per year. And the breakdowns and other unexpected problems reduce the efficiency to 90%. Okay. And they employ 86 drivers who work on average of 220 days per year, but the illness and other absence reduce their efficiency to 85%. If there is a shortage of coaches in the company can buy extra one coach for $110,000, or they can hire them for $100 per day. And if there is a shortage of drivers, they can recruit extra one driver at the cost of 20,000 per year, or they can hire them from an agency for $110 per day. So how can the company approach its tactical planning? So let's see here. I suggested I suggest you to follow the step by step of the overall approach that I introduced you earlier. So the first step, we will translate the forecasted demand into the resource that we need. So the demand is 400,000 full day passengers. So for this one, how many coaches we need? So I will write here for coaches. We need 400,000 because one coach they can serve 40 passengers, right? For one day, and 1 year they will work in 300 days. So it means the total coach days they can serve is 40 times 300. So we have the total coaches we need is 400,000 divided by 40 divided by 300, and it's equal to 333.33 coach people. Okay, it's what we need. And how about the driver? So we have okay, just calculate for the coach first. For 750,000 half-day passengers, how many coaches we need to serve those half-day passengers? So it's equal to 750,000 divided by also 40 passenger per day and 300 days per year, and because it's only half day, so we divide it by 2. So we have the total coaches they need to serve those 750,000 half-day passengers is 31.25 coaches. So total demand we will need 33.33 plus 31.25, so we have 64.58 coaches. So based on the forecasted demand, we can calculate the coaches that they need is 64.58 coaches. Okay, and here we can see the driver only work in 220 days per year. One coach will work in 300 days per year, but one driver only work 220 days per year. So one coach will need 300 divided by 220 drivers. Okay, one coach will need 300 divided by 220 drivers. So when we need 64.58 coaches, we need 64.58 times 300 divided by 220 driver. So we will have the total of drivers we need, that is 88.06 driver. Okay, that is equal to this 64.58 times 300 divided by 220, and we have the total driver unit is 88.06. Then okay, we already finished the first step. Then the second step, that we calculate what we have, and we have 61 coaches. We have 61 coaches. Then however the efficiency is only 90%. Okay, so it means we only have 61 times 90%. So we only have 54 . 0.9 coaches. Okay, this is the reality that how much coaches we have now. That is 61 times with the efficiency is only 90%. So we have the total is 54.9 coaches. And how about driver? We have 86 driver now. However, the efficiency is 85%. So 86 here is the in ideal uh, condition, that is they work 100% efficiency. Uh, However, in reality, the efficiency is only 85. So we actually only have like 86 times 85%. So we have like 73.1 driver. So the next step, we will compare what we need. We will compare what we need and what we have. So we already finished calculating the step 1 and step 2, and what we have is uh, based on the forecasted demand, we can calculate of the result we need, that is 64.58 coaches and 88.06 drivers. However, what we have now is only 54.9 coaches and 73.1 driver. So we find the mismatch, we find the gap between them. So we still lack of 64.58 minus 54.9. So we lack of 6, we lack of 9.68 coaches, and the driver we lack of is 88.06 minus 73.1. So we lack of 14.96 driver. Okay, so in the fourth step, we will find the alternative plan and compare which one is the best one. So here I can suggest you some alternative plan. First one, we will hire for the cost first. Okay, so first we can see here, we can buy extra coach if we we have the shortage. We can buy extra the coach with the price 110,000 per one, or we have another option is hire them for $100 per day. So the first option is we can buy 10 coach, or we can hire 10 coach, or we can buy 9 coach and hire 1 coach. Buy 9 and hire 1 coach. So how can we calculate the cost? So if we buy 10 coach, we buy 10 coaches, the cost we have to pay is 110,000 times 10. If we hire 10 coaches, we will have 10 multiplied by 100 per day and they work 300 days per year. So the cost for 1 year is equal to 10 multiplied by 100 and multiplied by 300. And the third option is we buy 9 coaches and hire 1 coach. So the cost is equal to 9 multiplied by 110,000 plus 1 multiplied by 100 and multiplied by 300. So we have the cost for them. So after you compare those three options, maybe you can suggest other alternative options and you compare which one will give you the minimum, the smallest cost. You will choose that plan. And the same for driver. You also can have 2 options that you recruit extra 1 driver with the price $20,000 per year, or you can hire them from another agency for the price that is $110 per day. So I also suggest you 2 options. Maybe you are recruit 15 drivers, or you hire 15 drivers, or you recruit 14 drivers and hire 1 driver. So you also help me calculate the cost and choose the option that give you the smallest cost. Then after you choose that option, you implement that option, that plan, then you monitor that plan and see its performance. And for more detail, I also put the solution for you here. If you cannot catch up what I told you earlier, you can read here for more detail. And here I also give you how to calculate the cost. But here there is a small difference, because here we use 9.68 to times with 300 times with 10 when we hire coaches. However, because we cannot just hire them with 9.68 people, so I just make it 10, so it will be easier for us. Okay, and it's the same here. We can just use 15. And also help me calculate the third option that we hire 14 drivers and sorry, we recruit 14 driver and hire 1 driver. Okay, so far is what we need to learn today, and next week we will learn about the aggregate planning strategy. Okay.